Yeah, there we go. Number 3 from this section. We're talking about understanding the basic rules of exponents, something that I'm guessing you've come across before. Real quick justification for each. Let's just use a simple example for each. Let's say our a was equal to 4. No, let's say it's 4. Let's say like a is equal to 5. So, as a quick example, let's say I had 5 squared times 5 to the third. Okay, well, what does 5 squared mean by definition? It means 5 times 5, right? And what does 5 cubed mean? It means 5 times 5 times 5. So here I have 2 5s, and here I have 3 5s, and the end result is 5 5s. So what do? We just added the exponents, right? You just add up how many 5s you get, and that goes as your exponent. So that justifies, really quickly, the product rule. Now, technically, I've only shown it for integer values, or not even, I've only shown you whole numbers, actually. But the product rule, actually, we apply it regardless of if I have a integer exponent, or even if you have any real number exponent. We treat the same way. You're still going to apply that same rule. Okay, what about the quotient rule? Here's a quick justification. Let's use 2 as a base instead this time. Let's say 2 to the third divided by 2 to the... Actually, no. Let's say 2 to the fourth divided by 2 to the third. What is 2 to the fourth? That's 2 times 2 times 2 times 2. 4 2s, right? 2 to the third is 1, 2, 3. And what do you do? If you're dividing, you just cancel. So in essence, you're just subtracting however many you had, right? And with 2 to the 1, right? 4 minus 3. So that justifies the quotient rule. And then power rule, what does power rule say? It says if you take a power to another power, then you're just multiplying the powers together. And where's a quick justification for that? Now, the justifications I'm doing is only for integer values. But again, we're just going to apply the same rules for any real number values. So, let's use 2 again. Let's say 2 to the second to the third power. What does that mean? It means 2 to the second is 2 times 2. And to the third power means multiply that 3 times. So what do I get? I have 2, another 2, another 2. So I have 3 sets of 2, which is 6, right? 2 to the 6. I get 6 2s. How do I get that? I just multiply the exponents. 2 times 3. 3 sets of 2 is 2 times 3. So that's the power rule in essence. Okay. One thing I want you to note here about these rules. The product rule, it takes when you're multiplying, takes this action of multiplying, and it says, okay, just add the exponents. Quotient rule says, okay, you take this action of dividing and you just subtract the exponents. And the power rule says you take this action of taking a power, and as far as the exponents are concerned, you just multiply the exponents. So in a way, you have this multiplication related to addition, division related to subtraction of exponents, and power related to multiplication of exponents. This is going to come into play later when we talk about the logarithmic functions in a future section. Okay, one more thing to note. This is what we're going to need for the next set of questions. But if you have a to something equal to a to something else, well, since this function is 1 to 1, and these x's are, you're only guaranteed to have one particular output, right? So that means that these x's must have also been equal to each other. x1 must have been equal to x2 in order for these guys to have been equal, for a to the x1 to have been equal to a to the x2. It's a pretty obvious fact, but it is going to serve us in this next group of questions. So what is this next group of questions? Let me show you the first one. Number 8. I've got 2 to the x equal to 64, but in order to apply that rule I just talked about, I want it to look like 2 to the x equals to 2 to the something, right? What is 64? 64 is just 2 to the 6. 2, 4, 8, 16, 32, 64. 6 to the 6. So then, now applying the rule, okay, the exponents must be equal to each other then. So x must be equal to 6. And yes, indeed that is the case. There's your answer right there. Boom. Done. So number 8. Done already. Easy. Okay, number 9. 10 to the x equals to 0.1. But what is 0.1? That's really just 1/10, right? It's 0.1. Okay, now it's looking more similar to like this base that I'm after. I want it to look exactly the same. 10 to the something though, right? So this should be 10 to the x equals to 1 over 10 is just 10 to the negative 1 power. So now set the exponents equal, x equal to -1, and oh, I'm actually done already. Done. X is equal to -1. So that was number 9. Easy peasy. That was number 9 just now. Okay. Going right along to number 10. Okay, number 10, I got 10 to the 2x equal to 1,000, but 1,000, I wanted to look like 10 to something. 1,000 is just 10 to the third power because I got 3 zeros. And 10 to a power is just the number of zeros, right? Okay, so taking the exponents equal to each other, I got 2x equal to 3, which means x must be equal to 3/2. Done. Now, it's kind of interesting here, like, just think about the original question. Looking at it right off the top, it's not really obvious to me that x is 3/2. But after just a slight, couple steps, and oh yeah, x is 3/2, so let me make this whole equation work. So that's pretty cool. Okay, next one. Okay, number 11. -2 to the x. Because a -1/2. Okay, first thing I see that they're both negative. So why even bother dealing with those? Just divide both sides by -1. I got 2 to the x equals to 1/2, right? Easy step. And now what is 1/2? We've seen something like this before, but 1/2 is just 2 to the -1 power. So I got x equal to -1. And I'm done already. There you go. Number 11. Number 11 down. Okay, on to 12. 12 says 3 to the -x equals to 9, but I want to write it as with the base 3. What is 9? 9 is just 3 squared. So setting the exponents equal, -x equals to 2. That means x equal to -2. Man, these guys are easy. Okay, so yeah, maybe good giveaway question to put on an exam. Although, look, I'm expecting these to get a little harder as we progress. Okay, 8 to the x equals to 2. Okay, now it doesn't look like how I want it to look, right? I have different bases clearly, but you should recognize 8 as a power of 2. What power of 2? The third power. 2 to the third is 8, right? So I'm going to replace this 8 with 2 to the third. And keep everything else the same, yeah. What did I do just now? I took this 8 right here, I replaced it with 2 to the third because that is 8 still yet, right? So 2 to the third to the x is equal to 2. Okay, now my rule of exponents says if I take a power to a power, just multiply the powers, that's 2 to the 3x is equal to 2. Now 2 is just 2 to the 1, yeah, just to help me out here to see when I set these exponents equal to each other, that means 3x equal to 1. Then solve. X is a third. Okay, still not very bad, right? Okay, 14. All right, 14, I got a half. I'm gonna rewrite this question this time because it requires me to think a little bit. Okay, 1/2. I'm looking what common base do they have, and the obvious choice again for me is 2. What is 1/2? 1/2 is 2 to the -1. Right, so I kind of did that same trick, replacing this 1/2 with 2 to the -1. Same trick as when I replaced 8 with 2 to the third, right? Don't forget to include that extra yet. And what is 16? 16 is 2, 4, 8, 16, 2 to the 4th. Right, so I got 2 to the -1 to the x. And now I'm going to apply my rules of exponents. That's 2 to the -x. -1 times x is -x. Is 2 to the 4th. So now I set my exponents equal to each other. -x equal to 4 means x is -4. Oops. There you go. Didn't box it this time, I just highlighted it. But let me just box the PC. Okay, 14 done. 2 more to go. All right. Number 15. 2 times 2 to the 2x is 4 to the x. This is 4. Okay, Well, first thing I want to do is just change things to look like more like 2 to the somethings, right? So I'm going to just keep this here, 2 to the 2x. And 4 is 2 squared, right? So same trick again. This 4 to the x is being replaced with 2 to the second. That's 2 to the x. 64, let's also write that as 2 to the 6th power, right? Okay, so this is 2 times 2 to the 2x is equal to 2 to the 2x, right? Multiplying these exponents together. Okay, a nice thing happens that these guys are the same. So I'm going to move this over to the left side of the equation. I've got 2 times 2 to the 2x minus 2 to the 2x is equal to 2 to the 6th. So I just moved this guy over to the left. That's all I did. And okay, here, look, I got 2 to the 2x's and minus 1 2 to the 2x. So this guy just becomes a regular 2 to the 2x. You see that? Here, let me write it like this so maybe it's more obvious what's happening. This is 2 to the x's minus 1 2 to the 2x, yeah, or like this. See, so I had 2 of them, I subtracted 1, so now I have only 1 left. 1 2 to the 2x left. It's 2 to the 6, and now I got the form I was after. That means 2x equal to 6, which means x is equal to 3. There we go, number 15. One more to go. Okay, number 16. Don't be intimidated by fractions, guys. It's not bad, trust me. It's not a hard question. I know it looks kind of intimidating because you got these fractions and you're like, I don't like to do fractions, but don't worry, you're gonna be okay. Because watch this, 4/9. 4 is 2 squared, right? And 9 is 3 squared. So, I'm sorry. Let me write the question again. Just copying the question right now, so you can see what step I'm taking here. Okay, 4/9, yeah, is just 2/3 squared. You see that? So 4/9 becomes 2/3 squared. And then that is what's being raised to the x power. Okay, this is multiplied by 8/27. 8 is 2 to the 3rd power. 27 is 3 to the 3rd power. So 8/27 becomes 2/3 cubed. How did I know to look for 2/3? Well, I kind of suspected it was going to be that because looking at that. But I also know that 8 is a power of 2. 27 is a power of 3. So this, 8 over 27 became 2/3 to the 3rd power. And now that whole thing should be raised to the 1 minus x. Okay, now let's apply the rule of exponents here. And rule of exponents says these buggas should be multiplied together. So 2, let's do it one at a time. 2 to the 3rd, 2/3 to the 2nd power to the x should be just 2/3 to the 2x power, nice and clean. This is 2/3 to the 3 times 1 minus x, which is 3 minus 3x power. Yeah, that's equal to 2/3. Okay, now another rule of exponents. I'm multiplying two things. They got the same base. They got the same base of 2/3. I'm multiplying them together. Rule of exponents says I should just add the exponents together. So this is going to be 2/3 to the 2x plus 3 minus 3x. Now let me go ahead and carry out this addition here. I'm going to do it right. Replace this what's written here. 2x minus 3x is minus x. So I'm going to end up with minus x plus 3. Okay, now I'm going to rewrite this as 2/3 to the 1 power so I can just see the comparison more clearly. And here's where we're going to loop in. negative x plus 3 is then equal to that 1. Yeah, same trick we've been using this whole time. And solve. That means x equal to negative 2 is x equals to positive 2. So there you go. X equals to positive 2. Easy. Yes. All right, well, that one actually wasn't super easy, but no, it wasn't bad, right? It wasn't bad. Okay, guys, that's it for this video.